Hey, everybody. I'm Chris Preimesberger, editor of eWEEK. Thanks for joining us today on eWEEK eSpeaks. Our special guest today is the co-founder and CEO of Splice Machine. His name is Monte Zweben. Monte, welcome.
Thank you very much. Glad to be here.
What a name, Splice Machine. I love that. That's a very creative name for a software company, or any company for that matter.
Yeah, it's all about taking very large data problems, usually underlying an application, spreading out the computation on many different systems, and then splicing the results back together again to achieve scale and performance.
Yeah. So basically, as I understand it, Monty, Splice Machine is a cloud service that can spin up a platform for data scientists or other IT people for specific use cases. Can you describe the high level of what the company does and what problems it solves?
Sure. Sure. And Spice Machine is a combination of compute engines that would typically take a IT organization, three different teams to put together three different engines and glue them together with different integration code. And instead of having to spend the money on the three different engines and the three different teams to integrate them, they get one integrated compute engine.
Hmm.
And we call it a converged SQL platform. It is an operational database that looks and smells like traditional relational database management system. It's ACID compliant, does very fast lookups and changes, but scales out.
Hmm.
And it's also an analytical engine, just like a data warehouse or a data mart or something that might be an in-memory parallel processing engine. Spice Machine has those computations directly on the same platform. Some people call that transanalytical or maybe HTAP, but it's a combined transactional and analytical platform. And the last compute engine that we've integrated is the machine learning workbench. Typically, people move data from operational resources to analytical resources and finally send them over to file-based machine learning engines. Well, we've inverted the whole process. We put the machine learning into the database. So three engines, analytical, operational, and machine learning in one.
Wow. And it's all automated and very simple to use. I saw you showed me a demo earlier. Monty, why don't you show us a quick demo
Sure.
of how easy it is to spin up a use case or spin up a database?
Excellent. Well, here we are inside of a Splice Machine cloud service. I've just authenticated and come into my dashboard. But if you wanted to create a new cluster, it is as simple as this. You simply name your cluster. Let's say this was a fraud type of application, and you specify how much data you're going to ingest into Splice Machine, where you need fast lookup, or you might be changing data. This is where row-based data sits for ACID compliant transactions. But perhaps you have analytical data that's sitting out in S3 that you need to analyze at the same time. That's external data. And then you specify your compute power. How much compute power do you need for your transactional application? How much compute power do you need for analytics? And then you specify how many active data scientists and engineers might want notebooks to be able to do data engineering and data science. You specify your backup frequency, and you go to your next screen here, give some credentials for security, check the box that you've read the terms and conditions, and hit the launch button. And I won't do it now, but it takes 10 minutes. And what happens is suddenly Kubernetes lights up and provisions all of the proper containers organized into pods out using Helm charts and a Kubernetes operator, and creates a new cluster on Splice Machine automatically, and provides the ability to have notebooks, a machine learning manager built on ML flow, and a whole tracking system. And you can see here that you have the ability to literally get these notebooks on the fly, look inside of them, and see that you can interact with Splice Machine here in a polyglot way, meaning just issuing SQL across the various paragraphs here, and you can just see a notebook that's actually executing SQL, as well as another example of a notebook that is actually doing machine learning, where a data scientist might be using some SQL and then launching down into Python and actually doing classic machine learning inside of Python, but also being able to actually compare and contrast their experiments using MLflow, the metadata capability for managing essentially machine learning experiments that enables you to compare and contrast your different experiments, what parameters you use, what algorithms you might be using, and then compare the metrics of their predictive capabilities and accuracy against each other, and then eventually deploy them. But that's how easy it is to literally put together a Splice Machine cluster and be able to connect to it from your applications in Java or your applications in Python or whatever language you want to use, as well as getting your embedded data science workbench.
Wow. If you're a data scientist and you're looking at all that, you're just like going, oh my gosh, I'm in heaven.
It makes it easier for them. It really does.
Oh, yeah. It connects so many dots, in the cloud and in your own data center if necessary, correct?
That's right. And one of the cool things about this Kubernetes architecture, it works on any cloud, any public cloud. It works both on, of course, our account where we're demoing today, but even more importantly, we literally deploy and provision these clusters on a client's account. So they get the isolation they want for security, and they get to use the same pricing that they get for their entire infrastructure, and even consume the credits with which their public cloud vendors may provide them. So they have full control over that environment. And even coming out this quarter is the ability to take this same Kubernetes architecture and deploy that on premises for customers so that they get that same elasticity and that same capability that containerization gives you on their on-premises virtual machines. So we're very excited about this new architecture built on Kubernetes that combines both analytical, transactional, and machine learning componentry, but it's all automated.
Okay. Monte, can you run us through just a quick idea of a use case? We talked about the credit card one. I like that one. Could you just maybe touch on that one a little bit, how it works?
Sure. One of our best customers is one of the world's leading payment companies, credit card company. They have a very important process that is called fraud dispute resolution. This is where you or I might see on our mobile banking app a pop-up that said, we just purchased 20 gallons of gasoline from a gas station in Nebraska, but we're sitting in California or in New York. We know it's not ours. So we issue a dispute about that credit card transaction. Well, before now, it used to take months before that dispute would be resolved.
Yeah.
And the payment company wanted that to happen in days. In order to do that, they needed a lot more clean data to be available to this application. This application was an old application.
Yeah.
And this is a story about application modernization. It was written on DB2, traditional relational database system. But now they needed not months of transactions, they needed years of transactions to be able to provide the call center, the merchant banks, the consumers, and the merchants with the right information at the right time to resolve these cases. I'm happy to report that now they can do it in days because every credit card transaction for this company, which is the majority of credit card transactions in the world, stream onto Splice Machine seconds after the mobile payment or swipe, and literally is available for you or your bank to access in milliseconds, and powers a very large call center to do dispute resolution. It's a multi-petabyte database that fields millions of queries a day while ingesting billions of records. And that's what scale out can provide for you, even on old code that worked on an old database.
Wow.
You essentially can modernize on scale out.
So Cobalt, it can help Cobalt systems.
Even Cobalt, old PL1. We have one customer that's taken a PL1 system and converted it over with a compiler, and it works on Splice machine, almost with no changes to the DB2 code. And we have partners that are literally able to compile old Cobalt code into Java code that accesses Splice machine and gives them the ability to not just modernize programming language, but to literally now take their applications and extend them with new capabilities like AI in a moment that would take years. Literally being able to take an old COBOL application and in weeks be able to compile it into Java and then extend it with a machine learning model. It's truly a brave new world that's rejuvenating old applications, not just modernizing them to the cloud or to a new programming language, but literally breathing artificial intelligence into them.
Wow, that's astounding. What this app can do. I'm bowled over by it. So Monte, our time is just about up. Can you just summarize the business value here at the 30,000 foot level, even though none of us is at 30,000 feet right now with the pandemic going on?
That is true. But to summarize, we built a data platform that enables companies to build new applications and to modernize old applications on a new architecture that makes it easy to exploit data and to inject artificial intelligence. It is the only SQL scale-out relational database management system with built-in native machine learning.
Okay, that's great. Monte of Splice Machine, Monte Zweben, co-founder and CEO of Splice Machine. Thank you very much for enlightening us today at eWEEK eSpeaks.
Thank you, Chris.
Okay. All right, and everybody else out there, have a great rest of your eWEEK. Thanks for joining us on eWEEK eSpeaks. Go to eWEEK.com to hear more conversations with IT thought leaders.